Hello everyone, welcome to the Skill Talk. Let's continue our vibration series. So in today we are going to discuss something more about phase. So normally in the vibration analysis field, we almost everyone know one sentence that there is always a 90-degree phase shift between the acceleration, velocity and displacement, right? But there is one problem here that most of us just remember the numbers that there is a phase shift of 90-degree, but normally we don't understand that why this happens and how it really works. So in this video I am going to explain the phase shift in the simplest possible way. There is no worries, there is no heavy maths, just a motion, timing and the common sense. Just this is what that we have to use to understand this logic. So if you definitely understand this video, then you will never be confused about the phase shift again, that why there is always a 90-degree phase shift between these three, right? So first very important thing is this, that phase shift is not a sensor problem. It's neither any kind of a magic done by the software. It is just simply a pure physics, or you can say the timing, right? So if you will let's take one example. Imagine a shaft or a spring that is moving left to right. Okay, that is moving left to right. So there are three different questions that normally we can ask about this motion. So the first question will be that how far did it move? So we all know, we already discussed this in the last videos. It's known as the displacement. The second question will be how fast is it moving? That also we have already discussed, is known as the velocity. And the third question is this, that what force is pulling it back? That is acceleration. This is also we have already discussed in our phase series, right? So these three describes the same motion, but they cannot reach the maximum at the same time. We know this, right? And that is where the phase shifts come from. So now we'll discuss that how this phase shift happens. So let's imagine one vibration cycle like a clock. Okay, so at 0 degree what will happen, that here the shaft is at the extreme end. Okay, so it stops for a moment before changing in direction, right? So once the shaft is moving towards extreme end, definitely the shaft have to stop just for very fraction of seconds to change its direction, right? So this maximum extreme end is known as the displacement. And at this location what will happen, since the shaft is about to change its motion to another direction, so velocity will become 0, right? So that's why at 0 degree what will happen, the displacement is maximum and velocity is 0 in this case, right? So now let's say that the shaft crosses the center, because now its shaft is almost near to the center. So this is where it will be having the fastest speed, right? So at this location what will happen, at 90 degree, so velocity will be maximum here and displacement will be 0 because we are near to the center. So notice this thing very carefully, that maximum speed happen after the maximum displacement, right? First was the maximum displacement, then it was maximum speed. So the delay is exactly 1/4 of a cycle. If you imagine a clock, so at let's say my needle at 0 degree and then it's moving towards the 90 degree. So there is a phase shift of how much? Around 90 degrees. So that's the reason that why there is a phase shift between the displacement and the velocity of 90 degree. I hope you understand this very clearly. Now the last thing is the acceleration. So what is the acceleration? Acceleration is the force, if you remember, that pulling the shaft back, right? So the force will be strongest when the shaft is stretched the most, right? So definitely the acceleration will be always opposite to the displacement. So whenever you will find the displacement is maximum, so acceleration will be minimum, right? And whenever there will be the acceleration is maximum, and then the displacement will be minimum, and whenever the displacement is maximum, the velocity will be 0, right? So this is how why there is always a phase shift between displacement and acceleration. How much? It's because they are both are opposite. So what is the phase difference between both? It's 180 degree. Okay, so it's just you have to imagine this thing, without using any complex formula, sine theta, cos theta. Just imagine logically that how that shaft is moving, and you will automatically get to know that why there is always a 90 degree or 180 degree phase shift between these three, right? I hope this concept is very much clear. So now we will be understanding the differentiation. Okay, so now comes the most important idea of this video, where we convert the displacement to velocity. So we are not, remember, we are not changing the motion, we are changing what we are measuring, because I am not saying that okay, let's push the shaft to another end, right? Just my calculation is different, right? So we are changing that what we are measuring. So velocity simply, what velocity simply asks that how fast position is changing, right? So displacement is that how far it's moving, and the velocity is that how fast it's moving, right? So maximum change ever happen at the peak, so it happens somewhere between the peaks, right? Because velocity will be maximum somewhere between the peaks. So that point is exactly 1/4 of the cycle. So that's why the one, and what is a 1/4 of cycle? It's equals to the 90 degrees. So that's the reason that why whenever I will be differentiating the displacement and I am getting the velocity, so what will happen? The phase will be plus 90 degree. And whenever the next again I will differentiate it, so what will happen? My velocity will be converted to the acceleration again 180 degree. Again 90 degrees. So overall what will happen? The angle between the change between the phase change between the displacement and the acceleration will be 180 degree. So it's just a timing. There is no maths here. It's just a timing. If you will understand with the logic without mathematics, it's just a timing of the shaft, movement of the shaft. So that's the reason that why these three are not always equal, right? So now let's discuss the next part, that is the integration. Okay, so integration is the opposite process, right? So this part is very important, and normally it's get misunderstood. So integration means, what the integration means? It simply means that adding up everything that is happened in the past. Okay, clear? Integration means adding up everything that happened in the past. So acceleration, whenever I am converting from acceleration to velocity, that means I am keep adding acceleration over time. Okay, and the same thing if I will convert velocity to displacement, what that mean? That I will be keep adding velocity over time. Okay, right? So in the real world, the sensors, we know that the sensors are not perfect. There is always a very minor, very tiny error will always be there because of electronics, small bias, some kind of electronics noise, or some kind of a temperature drift. So there will be always very minor error will be there. So this error is very, you can say very slow, or you can say very small, and we can't even considering it, we can't even see it, and definitely we are not even considering it. But since the integration cannot tell the difference between the sensor error or any kind of a minor kind of variation, and since we know that what is the integration always adds up, right? So it keeps adding the things. So what will happen in the first integration? Let's say I did my first integration, so the small error will become slightly more, or you can say a slightly drift, you can say the slightly velocity drift. Again I will integrate it. What will happen now? This drift will become more large. Okay, so that's the reason that whenever we are taking the vibration by using our accelerometers, so first whenever I am taking the raw data as acceleration, so whenever I will do the first integrate, that small error slightly make a drift towards the velocity, and again I will integrate then, and if I will see the displacement in my analyzer, I will see a very huge value there. But actually in practically, if you go and measure the machine displacement by using the proxy probes, the displacement will be very low, right? So that's why even when the machine is healthy, displacement always starts fluctuating, or you will see that the displacement value will be always high, or you can say the displacement starts walking away. So now I will take one example here. Imagine that our car speedometer is there, and it's having the error of let's say very minor error of 0.5 km/h. So if you will calculate the distance by doing the integration, you will be getting that after 1 hour there will be some minor variation of 500 meters, right? So the same logic applies to the vibration. I hope now it's things are very much clear. So let's conclude this video. So what we have understand here, that the position, or you can say the displacement peak, it's at that position what will happen? When the displacement is high, the velocity will be 0, and when the velocity will be high, the position will be at the center, or you can say the displacement is 0. And when the force will be high, or you can say the acceleration will be high, because it's exactly opposite to the displacement, right? So this is what the real meaning of phase. And always remember one more thing, that integration remembers everything. right? So low frequency noise looks like a real motion. So because it's always get amplified, that's the reason that why by using the accelerometers we are not getting the displacement, exact value of the displacement, right? So I hope things are very much clear. I will be let's come to our last part of our video regarding the questions. So first question will be for you: when displacement is at maximum, what is the velocity at that moment? Okay, so 3 options are given for you here. You can just put the answer in the comment section. And the second question is this, that why does velocity lead displacement by 90 degree? Again, the 3 I have given you 3 options, and please mention your answers in your comment section. And if you could answer these questions correctly, that means you truly understand the phase shift. Please like, share and subscribe our Skill Talk for more such videos. In the next videos, I will be bringing you some more another topic. Till then, take care. Bye. Thank you for being with the Skill Talk.